I'm Ryan Fox. I'm going to be talking to you a little bit about adding mobile signing to your dApp. Anybody recognize that guy? That was me before Algorand, and this is me now, right? So full-on algogator, thrilled to be here. I've been doing this role for a little while, and I really enjoy doing that, working with the developer relations team. Maybe you've seen me on Developer Office Hours. It's a show that I run twice a month. We're actually going to try to move that to more frequently as we get into the new year. Connect with me on LinkedIn, Twitter, wherever it might be. It's always Ryan R. Fox. The middle initial is important in there. All right, so we're gonna talk a little bit about WalletConnect here and understand. I want to kind of set the stage, tell you why you're here and what you're going to learn from this session. All right, so I want to know who are my developers here. Yes. Awesome. We've got some stuff for you. So I want to make sure that you understand that why we're here, why we're going to do this here is because we're all about connecting dApps securely with an end user is very difficult. So that's really what WalletConnect is for. That's really what it solves. That's what this talk is about. So as a developer, what you're going to learn about is how to integrate this protocol into your dApp. And if you're an end user, what you're going to be able to do is to learn how WalletConnect really can protect your dApp experience and therefore encourage those dApp providers to be implementing this protocol. Let's see here. So, why WalletConnect? Because, I got this one. So my speaker notes are a little behind here. So why WalletConnect? We did that one because it's hard. All right, and that's exactly what WalletConnect is there for. All right, so for our agenda, here's what we're going to cover, guys. All right, we are going to cover 3 different pieces here. We are going to be covering some demos for dApp integrations, and we're going to spend most of our time here on the signing request, what's in there. So that's for my people who raised their hands already, our developers. Who are my sometime developers? All right, so for you, we definitely have some content there. We've got the basics. What we're going to cover there is an introduction to what is the WalletConnect protocol, as well as some dApp design. I'll introduce a new dApp for you, and then we'll get into the development setup for you. And for anybody else who does not identify as a developer, we've got stuff for you just the same. Don't worry. We're going to be looking forward to see what we've got coming down the pike with the enhancements to the WalletConnect protocol, as well as enhancements to the Algorand mobile wallet. And we'll wrap it all up with a bunch of resources for you guys to walk away with here at the end. So let's get straight into it, starting here with the basics, and we'll get into these 3 points here. All right. So what is the WalletConnect protocol? All right. So the WalletConnect protocol provides secure remote signing communication between a blockchain application and your wallet. All right, and what that looks like is, or the reason why is because it's going to allow dApps to request authentication from an end user while maintaining the private keys on their mobile device. And that's very important to ensure that as an end user, you are keeping those keys with you, away from exposing them to the dApp. And what is a couple of the goals that WalletConnect have are to reduce the end user steps for connecting between these platforms, between connecting with dApps to their mobile wallet, protect their activity as they're using those dApps, and then allowing any blockchain to be able to connect to any other dApp. So they really are agnostic. WalletConnect is a protocol. It is not a blockchain. It doesn't have a token. It is free and open source protocol that we are implementing within the Algorand wallet. All right. And the way that this happens is this QR code in the middle. It provides a method for the dApp to present who it is and make a connection using QR codes for the desktop, or a deep linking if it's just if the dApp actually ends up in on the mobile device itself. And that provides for pairing, and we'll see what that looks like. Importantly, that communication is symmetrically encrypted so that the messages then that are sent between the two peers are handled encrypted, and the peers, the bridge server that's in the middle doesn't get to see any of that communication. So what does it look like? Well, all of you in this room have already seen it and used it. I know that because all of you came to this website here to claim your AlgoGator. And the first thing you had to do when you got to this page was click on that connect button. That was initiating a WalletConnect session, all right? So you chose that you were going to use your Algorand mobile wallet, and a QR code popped up. When you scan that with your, well, before, if you would have clicked this little button down here at the bottom of this copy to clipboard, you could have pasted it up. It provides the WalletConnect URI that describes how the dApp wants to connect to the mobile wallet, and this is part of the connection process, the handshake at the beginning. You probably didn't see that, but that's what that QR code says in there. All right, so what you did do is you scanned it, and then it made this. It asked you, do you want to connect to this dApp? And of course you do. You want your AlgoGator, and of course all the VIPs that were out there as well, they also got their AlgoGator. So for those that are joining online, we're thrilled you're here streaming with us. And I should remind everybody that this presentation and all of our presentations will be recorded, and they'll be posted on our YouTube channel when we're done with this, YouTube/Algorand. That's where all our stuff is. All right, so great. So you said that you wanted to approve the transaction ultimately to claim your NFT. You took a look at the I'm standing in front of it here, but the transactions came up here, and there were a series of transactions in order to make this happen. We'll see how that looks. And when all of those were approved, ultimately you got your Gator on that website. All right. So let's take a look a little bit about what does this WalletConnect design look like? What does the protocol design look like? So as I've said, like, it's an open protocol, and it is designed to communicate securely between dApps and wallets, right? So it establishes remote pairings using a relay server in between to relay payloads, messages in between. And those payloads are symmetrically encrypted so that when the initial communication is established, those are going to be encoded. The way that they are established is that typically the dApp will send the URI up to the relay server, and it will also present that QR code as we saw. And ultimately, then the connection is established when the client side, the wallet in this case, will accept that and establish its connection also to the relay server. Now so then thereafter, all of these messages can be exchanged securely between the two clients. So within the Algorand mobile wallet, we are implementing a WalletConnect client that talks to the relay server, and the dApps are doing the same thing, implementing a WalletConnect client that is connecting to the relay server, and they're exchanging messages over those. Okay, so yes, so the messages are going to go back and forth between, and of course, once they are approved, the key is on the mobile wallet only, and when that is used to approve the message, the transaction signing, it goes back and is executed by the dApp or processed by the dApp and ultimately sent out to the blockchain to be validated that way. All right, so I've got a demo dApp that we are going to take a look at, and my dApp is very simple. This is the button that we are going to push, and it's going to count things. Every time that you push that button, we are going to increment a counter. It is very exciting. All right, appropriate amount of laughter. All right, really what's happening here is that pushing the button is really a transaction request that we are going to set up inside of our dApp. We are going to implement that both as a smart contract, and then we're also going to use a React front end to interface with that smart contract. So every time that you, and then every time that the wallet then approves the transaction, the button will be pushed, right? And then the state transactions will happen. And ultimately what happens is that the counter increments. So we see there that we'll have a global variable just for the application itself that will increment. We've called it 3 times, therefore the count is now 3 in the global space. Later on, we are going to upgrade this application and we are going to do atomic transfers. So this is actually more of a common use case for dApps, is that they are going to require the end user to sign a series of transactions, an atomic transfer. And we know that all of those transactions must succeed, or if any of them fail, all of the intermediate steps, state transitions that had happened would be rolled back, and none of them will in fact be affected onto the blockchain. So we'll see the transaction request here as an app call plus a payment transaction. The backend smart contract will enforce those pieces, and if both succeed, then the counter will be incremented, and of course, one more time, we will, and we would see that it goes up to 5. The other thing that we're going to do in that one as well is we're going to add local state as well, so that we'll show that you, as a smart contract, you can do both updating state for the application globally, and we can also then determine which accounts have called the application and how many times they have called it. All right, so that's what we are going to take a look at. And let me tell you a little bit about the development environment that I've got set up on my machine here. So I am using the Algorand sandbox, which is a great tool for developers to quickly spin up their infrastructure. I am connecting to the testnet. So I have downloaded the repo and I have issued the command sandbox up testnet. And in about 10 minutes or so, it has built and used the fast catch-up command then to get us straight away onto the testnet. And then it exposes the endpoints that I can connect my dApp to in order to send some of my transactions. Other transactions and other queries, more importantly, that I will be pulling data from the blockchain will be used against the Algo Explorer developer API provided by Rand Labs. On the IDE and the SDK piece, I use VS Code, and you can use whatever editor you like, but I like VS Code. It has a very nice plugin for PyTeal and for Teal, so that it does syntax highlighting and really helps us be efficient in how we build our applications out. In this application, I am doing deployment using Python. So I'm using the Python SDK, and I am doing I have a front end that is built using Node.js. So I am using the Algo SDK JavaScript library as well. So those are the commands that I'm using there. On the front end side, of course, I'm using the Algorand mobile wallet. That's what this is all about. I've got Node.js and React, as I said. So that's what we'll take a look at. I think this is when we switch over to here. Good. So like I said, so I've got Sandbox running in Docker, and Sandbox again is a Dockerized container of our Algorand infrastructure. So we have the AlgoD node running. It is synced, as well as I have, it does provide an indexer instance as well. For the testnet, it does not turn that on. It is not in sync, so I don't use that. Again, that's why I'll be using the Algo Explorer APIs in order to get and make those indexer calls. But if you are a developer who wants to use a private test network, which is normally the way that I do a lot of my tests, you just do sandbox up, and it will build a private network for you, and it will actually build out a local indexer for you. So sandbox is the first piece of kit that we've got. The next piece that we want to take a look at is, just to show you that we're in sync here. We'll pull this up to the top. So as you can see, time since last block, that's a little scary. We better get in sync here, folks. We're going to assume that everything is okay. And Sandbox is running. The other piece that I want to take a look at is for my environment here. I am putting the mnemonic that we are going to use for creating the application. I have put it both in Sandbox for deploying it. So I write out a mnemonic file here to disk and store this here. And then we take a look at it. We'll take a look at that inside of our deployment script, how we've got that. Let me show you quickly kind of what this thing, let's see, do I have it running here? Yeah, like ultimately this is what we are going to see running, is going to be a simple application that connects to a given application ID that we're going to deploy, and then you've got that counter, and we are simply going to click the button to call to increment. So that's visually what it looks like, but let's go behind the scenes and see what it looks like to deploy our contract. So yesterday, Jason Paulos gave us a great overview, introduction, and went into PyTeal. I'm using PyTeal as well to write my smart contract, and I want to show you just sections of it and kind of build it up for you. So when I deploy the smart contract at the beginning, it will use the sequence here that is simply going to zero out or initialize the counter value in global state. So that's what you're seeing there. It sets it to 0. Not terribly exciting. The part that is more exciting in this version of the smart contract is the no-op. Every time that we press that button to call the application, what we are going to see is that we store it in scratch space, we load it, we load the current value out of scratch space. Of course, first time through it'll be 0. And then we're simply just adding 1 to whatever value that we had in there. And then we're going to put it back. So we're simply incrementing it. And then we're approving the this transaction and this program, I should say, allowing the transaction then to succeed and those state transitions to be committed to the blockchain. So that is our basic application there on the back end. And we are now going to deploy it brand new. So, well, actually, first thing we have to do is build this. So I have a little script here. I should tell you that this, all of this code here is available on GitHub in the Algorand-DevRel repo. So you'll be able to download all of this code and run it yourself. So that's what this is all about, making it easy for you guys to be able to do stuff. So here is our compiled teal. And the interesting part again in the button click is down here, where we will see this section here, where we are doing the storing of where we're getting the count, the current value of count, we're storing it, and then ultimately we are incrementing it by 1 and then returning. So there is our compiled teal, and we will now deploy it to the blockchain. And I'm going to deploy it from the command line using a Python script. And that's what this one does here. And it will send this transaction, create the application. The keys for this are loaded into the sandbox ahead of time. And now I'm a little bit worried that we didn't get in sync here. Okay, so we are going to move along and we are going to take a look at the application that is currently running from before. Okay, so thankfully I didn't delete it from before, and we are going to go over here to our program, and we are going to connect to this application. And the way that this works is we've now clicked the button within our application to connect. It has prompted us with the QR code here. And in the settings section here, I've already done the developer settings here. And I have switched from mainnet, which is default when you guys work, and what you guys should do is keep it there. As a developer, you should know that there are node settings to move to testnet. So that's what I have done. Another section up here at the top is the wallet connection sessions. So what you can do is go to that, and when you see a QR code like this, you click the scan button and you will connect to it. And it is really not giving me, it is really giving me a hard time today. So we are going to sweat a little bit more. We are going to go up testnet. And we are going to move along in our presentation a little bit, because this is going to take quite some time. It'll take about 10 minutes to do that. So let's let it do that, and I'll go and tell you about the what's to come, and we'll come back and do the demo thereafter. Let me just make sure that this is going. Okay, so that's going to take a little while, but we're going to come back. We're not going to be flustered. We are going to go back to the deck, and we'll come back and do the demo in a few minutes. Yes, right. Let's take a look about looking forward, what WalletConnect have for enhancements that are coming up. So WalletConnect are very much focused on recently deploying version 2 of the WalletConnect protocol. So the version that we have implemented that you'll see the demo of is WalletConnect version 1. It's about 4 years in the making that they've been doing that. It was very much born out of the Ethereum community. They have made it scalable so that we can enhance their URI scheme in order to make these transaction requests in the format that the Algorand wallet can recognize and be able to interface with. So in the version 2, what they're really focused on is being chain agnostic and really making Ethereum not be the only chain, or the EVM chains really be the only ones that it talks to. It makes it so that everybody's chain can be interoperable, and they focus on this using what they call CAPEs, or these chain agnostics improvements protocols. And there are a handful of these that Algorand are working to contribute to, so that the Algorand wallet can then be successfully upgraded to the version 2 protocol. When that happens, application developers will also need to upgrade their dApps to be on implement the WalletConnect version 2 protocol as well. It is a breaking change, so it is something that we will work with developers to make sure that they are ready for that. We will provide a mechanism for dApps, for the protocol to be able to select and to fall down if the dApp still is on version 1. It will be able to continue to work, and we'll support both of them simultaneously. Look for that to happen in the first half of next year. So yes, the WalletConnect is about getting chain agnostic blockchain identifiers, account identifiers. Some of the other pieces that they are really working on is making it more decentralized messaging. So they are going to have new message relays that are using gossip messages through all of the nodes, so that there are no more centralized servers. So that we don't just have to connect to a relay server. We'll connect to nodes, and those nodes in and of themselves will exchange those messages. So we don't have to rely on a single point of failure or a single infrastructure provider as well. And they are working very much on permission systems, so explicitly requiring wallets that can meet all the compatibility with all signed methods within that your dApp may implement. You can check that before they make the connection, so that you can ensure that the wallet that the user is connecting to can support all of the pieces that your dApp wants to utilize. and they are working a lot on speed and scalability as well. So pairing and sessions management are going to be enhanced to reduce bandwidth and be able to guarantee the message delivery as well. So currently, best effort. Going forward, they'll actually be able to have guaranteed message delivery. Lots of information about WalletConnect version 2 is available on their website. They've recently upgraded to their domain to walletconnect.com. So you can go there to their docs repository and read through what it is. We'll be doing more within the developer relations team, outreach to developers, dApps that have already implemented it, and we'll be communicating with you when the Algorand wallet is ready to support version 2. Very exciting what the Algorand wallet has coming soon will be to be able to show your NFT images displayed within your Algorand wallet. So you'll be able to have something like this, where you will have your account and you'll be able to see your collection of the various NFT projects that you hold NFTs within. So if you happen to have a whole lot of gators, you could go into them and you could see all of the different characteristics about those, the traits and so on, as you see down here, description and properties and details. So all of this stored within the metadata of the NFT will be able to be parsed by the Algorand wallet and displayed neatly within the user interface there. Again, this will be something that is on the backlog and should be coming soon. Very much looking forward to that. All right. The resources piece of this, the dApp, like I said, that you haven't yet seen the demo of, is available here in the Algorand-DevRel organization, and the repo is demo counter WalletConnect React. So you can get all the code that you're going to see there. There is another WalletConnect demonstration that Jason Paulos built a number of months ago when they first implemented it within the Algorand mobile wallet. That is in the Algorand organization, and the repository there is WalletConnect example dApp. All right, and of course I want to make sure that you guys are connected to us on our developer portal at developer.algorand.org. There's a link there to our Discord server. I want you guys to make sure that you're hitting that QR code, joining us there if you're not already.
Oh, that's
yes.
Is there a way to, like, when you're getting the Gator and you connect to the Gator smart contract, is there another way, like maybe a visual way that a user could know that you're connecting to the right contract besides looking at the ID, like maybe have some kind of NFT for the NFT for the contract, and then look that up on chain in your application?
So you were talking specifically about this piece here.
Yeah.
And okay, so tell me what the question one more time.
So, you know, like when you, I don't know, do a verification on your bank or something, you say you'll see this image if you know you're logging into the correct site for like a user. Because if you connect to this, you might look at the contract ID and be like, okay, I know I'm connecting to the right contract, but also not user friendly. Is there a way to maybe in the app like tie that to an NFT and then like look that up on chain, so and then you can display it on your site to make sure you're kind of authenticated to the right one?
Okay, so I think the question has to do with NFT as authentication.
Yeah, as a verification that you're connecting to the correct contract, because like, I mean, someone can spoof that site and then, you know, just.
Right, okay. So let's see here. We, as an end user of any dApp, right, you want to ensure that the user interface that you are connecting to is pointed to the right smart contract. Because the beauty, of course, of decentralized applications by design is that anybody can implement a front end and point it to the same back-end smart contract code. So I suppose if the dApp itself was saying that I am this NFT, but the NFT in and of itself is really just metadata pointing to someplace else in a decentralized file storage system. So I'm not certain that they would be able to get around that. I'm sorry, I'm not coming up with a solution to your question at this point.
I'm just trying to think as a hacker, try to give the users a little bit more like confidence that they're okay. I did connect to the right one.
Sure. Yes.
But
I'll think about this, and you could look. I would love to speak more about it. And yeah, there was another question up here. If you pass the mic.
So in fact, like my question is related to the metadata storage.
Yes.
And as well storing those images somewhere in the storage or IPFS or somewhere S3 or cloud. Like some NFT marketplaces, they have IPFS all the time, and if they wanted to see our NFTs in other NFT marketplaces, in fact, like we are using S3 on other things, right? So it is not compatible with other marketplace, and they couldn't be able to see the NFTs. Only thing is, like in the Algo Explorer, they can see only the information, but not the metadata. In the URL, we usually provide that, this is the link in the IPFS, or it's a link to S3 or whatever. How do we provide more URL links? And how do we provide the description as metadata or whatever, hashing, whatever? So how do we do that? So it is globally available in all NFT marketplaces.
Right. Okay. So the question having to do with how do we provide and reference metadata? How do we provide more than just that single link to an IPF? The Algorand Foundation have a series of ARCs, Algorand Request for Comments. And this is on the Algorand Foundation organization on GitHub. And in there, they have specified ARC3, which speaks exactly to this. So the general concept is that you will create well, first of all, you will upload your content to IPFS, be that the simple image file or whatever media you might have. And then that now has an address. And then you can write that into a JSON object, a metadata.json file, in a particular schema, and then hash that, and then push that to IPFS as well. That hashed address, or that address, is what you would then stick in your Algorand standard asset in that URL field, and then you would take the hash and you would also write that in there to say, this is where all of my metadata live to describe all of those additional assets that describe the traits and all of the bits of the of your NFT. And then, of course, any other marketplace would be able to access that information and present that within their user interface just the same. So I would encourage you to look for the ARC3 specification. Here it comes. That's the right one. Okay, so the way WalletConnect works is you connect the wallet using a QR code. We just vert like that, and then it's going to pop a connection. Do you want to connect to that? So that is running against my local host. Is this what you really want to do? I do. I got to push that button on this side, not on the screen. It says, great, connection successful, outstanding. All right, so and must be a UI issue there because we have not called it globally. So therefore there can't be any local, but we can't call it right now because we haven't opted in. So we have to do that first. So let's do that. Let's make an opt-in transaction. It pops it up. It shows you that this is an on-complete of opt-in. That's what it is. Do we want to do that? Sure, we could look at the raw transaction and we could prove it. We would know that, yes, all of this stuff means that it is going to the testnet, and it means that it is going to this account, our sender's account. And we want to actually do that. So let's approve that transaction quickly. Right there, confirm, yes, I accept. And very shortly, it will give us a response back. It's not going to increment the counter at all. All it's going to do is allow us to send a it's going to allow us to successfully make this button work, which is call to pay transaction, or I'm sorry, call to, call and pay to increment. All right, so this is a transaction, an atomic transaction, two transactions that are working together. So it has a call to our application here, right? That's just a regular no-op. And then the other piece that it has, and what the contract said, what it added in here was that you have to also include as a second transaction an algo payment of anything that's greater than 0. Okay, so we're going to send 0.1. This will work. So we will confirm this transaction right here. We will accept it, and momentarily, okay, so we're waiting for it to come, and we will see that it is approved, right? And then we see that the global counter went up to 1. I can't quite understand why the local counter doesn't want to say the right thing, but essentially it should have. I apologize. Okay, so we have very little time left here, but I did want to show behind the scenes to really to show you what is really going on in this application here for the payment and send transaction, the way that we are putting these transactions together and sending them out. So because we have to bundle them up as an atomic transfer. So let me get to where that is right here. We have 2 transactions here. We have transaction number 1. Let me get this out of the way, which is, that's actually the second transaction. Transaction 0 is the no-app call that is calling our application ID. The second transaction, TXN1, is the payment transaction, and the contract enforces that you're sending it back to the dispenser, to the testnet dispenser. So that's what that address is. And we had to send an amount that was at least 1 microalgo. So that's what we're sending. The way that this works is we create a signed transaction group, which is an array of transactions here. We will sign them, and we will, as we saw, we'll get it back, and we will be able to see that in our mobile wallet, approve it, and the state changes will be represented on the blockchain. So that is the quick demo. I'm sorry, it was a little rushed at the end there. So what we covered, of course, was, get to the last slide here. This is all the great stuff that we covered here today, right? The WalletConnect protocol, our dApp design, our integrations, and we took a look at the future enhancements. I'm Ryan Fox. I had a great time connecting with you. I hope that you enjoyed this presentation. We're going to make it better. We're going to make that code available online. Connect with me here on Twitter, LinkedIn, wherever you might find me. I'm Ryan R. Fox. And thank you.